Today I am going to explain some problems based on electromagnetic waves chapter. Let us see now a plane electromagnetic wave frequency 25 MHz travel in free space. EM wave is traveling, electromagnetic wave is traveling in free space. Electromagnetic wave frequency they gave 25 MHz. Mega means 10 to the power of 6 Hz. This is the frequency of EM wave that is traveling in the free space along the x direction. EM wave is traveling along the x axis. This is x, and for example this is y and this is z. And EM wave is traveling along the x axis like this. Right, when EM wave is traveling along the x axis, x direction, and at a particular point in the space and time, electric field they gave. At a particular point they gave the electric field as 6.3 j cap. That means electric field is along the y axis. Okay, and electric field magnitude is E is equal to, they gave as 6.3. Then the question is that what is the value of magnetic field? B value is how much? B value is how much? Then it was very simple to find out. That is, electromagnetic wave travel with the speed of EM wave. We write C is equal to E by B. From that I want to find out the B. That's why we write here B is equal to E by C we write. What is the value of E? E value, E bar, E is in vector form, but E magnitude if you want to find out, that you will get the 6.3 volt per meter. Then here we write E value as 6.3 and C value as 3 into 10 to the power of 8. 3 1 ja we write, 3 2 ja we write here, 3 2 ja 6 and 3 1 ja. Then here we will get the B value as 2.1 into 10 to the power of 8. Okay, Tesla we will get, Tesla. B unit is Tesla. I want the direction of the B. B at what direction? E is along j cap means y axis. Electric field is along the y axis and the wave is traveling along the x axis. What is the direction of the magnetic field? We know direction of motion of EM wave. Direction of propagation of EM wave. What is the direction of motion of EM wave? You know that direction of motion of EM wave is along the E bar cross B bar. Okay? That means velocity is along A bar cross B bar. The direction of EM wave they gave us, we got along the positive x axis. Means we write I cap, direction of EM wave is along the, EM wave is traveling along the x direction. Electric field is along y axis that they gave in this, that is j cap. E is j cap. Question B is direction is what? Here we write question mark. Then you know j cap cross k cap if you will get, then I cap we will get. That means B bar direction is along the k cap. That means B bar is along z axis. B bar is along z axis. Positive z axis we write here. Positive z axis. And that means we write like this. Positive z axis. And that means in vector form if you want to write, we write here 2.1 into 10 to the power of minus 8 k cap we write. Z axis is indicated by k cap, Tesla, right? This is the solution for this problem. Okay, take the screenshot and note it. Let us go for one more problem. The magnetic field in a plane electromagnetic wave is given by, the magnetic field is given. For electromagnetic wave, the magnetic field direction is given. The magnetic field is given by this 2 into 10 to the power of minus 7 sine 0.5 into 10 to the power of 3x plus 1.5 into 10 to the power of 11t Tesla. This is the magnetic field. Magnetic field of electromagnetic wave they gave, that is along the y-axis. They are asking to find the wavelength of EM wave, frequency of EM wave, and also they are asking the expression for electric field. EM wave has the magnetic field and electric field. Magnetic field expression they gave, electric field expression we have to find out. Then for this purpose we compare this one with the general equation. Magnetic field general equation is By is equal to B naught sine kx, either plus or minus omega t will be there. This is the general equation, okay? And Tesla, this is the Tesla. And when you compare these two equations, right, then we will get the peak value of when you compare both of them, we will get the B naught value as 2 into 10 to the power of minus 7 Tesla. This is the peak value of field. K we will, this is the kx, x multiplier is k, propagation constant 0.5 into 10 to the power of 3, and one more is omega t, t multiplier is omega, that is 1.5 into 10 to the power of 11. What they are asking in the question, the first question is that they are asking to find out the wavelength, lambda is what. In the second sub question, in the first question there is one more question is also there, what is the frequency they are asking. The second question they are asking that write the expression for electric field, what is the direction of electric field, and electric field equation we have to write. Okay, right. This wave is going along the x-axis, positive x-axis. That means here magnetic field along y-axis means electric field along the z-axis. Simply we have to find out the electric field magnitude. For the purpose we know first k formula we know, that is the 2 pi by lambda. We know this one. From this if you write the lambda formula, 2 pi by k we will get. That is 2 into pi value is 3.14 by k value is 0.5 into, or we can keep it as like this only, there is no problem, 2 pi into 2 pi by k value. K value we know as 0.5 to the power of 3, and this 0.5 is nothing but 1 by 2, it goes to numerator, then we will get the 4 pi into 10 to the power of minus 3. This is the wavelength in the meter, it is the unit wavelength we got here. Then the frequency they are asking, then we know omega is equal to 2 pi nu, omega is equal to we know as 2 pi nu. From that if you write the new formula, that is omega by 2 pi, omega by 2 pi, omega we know already 1.5 into 10 to the power of 11 by 2 into pi value is 3.14. We have to simplify this, 1.5 by we will get 6.28 into 10 to the power of 11. If you simplify this one, we will get 0.239 into 10 to the power of 11 hertz we will get. Okay, and then after that they are asking one more. What is that? The second question is what? Second question they are asking to write the equation for the electric field. Right, Ez equation we have to write. Electric field equation we write as E naught V is equal to B naught sin kx plus omega t. E is equal to E naught sin kx plus omega t we write. That's all, it was very simple. The same formula we write. But here we know kx plus omega t is this one only. But here we have to write E naught calculate, we have to calculate. When you know the B naught, it was very easy to find out the E naught. Why? Because, but we know C is equal to E naught by B naught. From that we write the E naught formula, that is C into B naught. Then E naught we will get as C is the 3 into 10 to the power of 8. B naught value is 2 into 10 to the power of minus 7. Then 3 into 2, 6 into 10, will get the 60 volt per meter. E naught value you got, you substitute in that, then we will get Ez formula as E naught is 60 into sine kx plus omega t. This when we write as it is. That means we will get as 0.5 into 10 to the power of 3x plus 1.5 into 10 to the power of 11 t. Okay, this is the expression for the electric field that is along the z axis. Okay, unit we write here volt per meter. Volt per meter. This is the solution for this question. Let us go for one more problem. Later I will close. Okay, let us go for the one more last problem. Light means here we can take as EM wave. Okay, EM wave is the light. EM wave with an energy flux. Energy flux means intensity of EM wave only. Intensity of EM wave they gave in the solution. First of all, whenever you want to solve the problem, you have to write the given values. If any figure is there, you have to draw the figure also. Intensity they gave as 18 watt per centimeter square. Okay, this we can convert into meter square. Watt by centimeter we write as 10 to the power of minus 2 whole square, 10 to the power of minus 4 meter square. Okay, centimeter means 10 to the power minus 2 meter. Centimeter square 10 to the power minus 4 meter square we will get as 18 into 10 to the power of 4 watt per meter square. This is the intensity they gave, energy flux. That is falls on the non-reflecting surface. Means whenever the EM wave falls on non-reflecting surface, that non-reflecting surface completely absorbs the EM wave. There is no reflecting surface. There is no reflecting at the normal incidence. If the surface has surface area they give as 20 centimeter square. You convert into meter square, that is 10 to the power of minus 4 meter square. Okay, EM wave is incidenting on the non-reflecting surface. That is a normal incidence. That is incidenting on certain area 20 centimeter square. The average force exerted on the surface during 30 minutes of time. 30 minutes time, 30 minutes means 30 into 60. 30 into 60, that is 1800 seconds. EM wave incident on the surface. During this, how much average force exert on the non-reflecting surface by the EM wave? That we know formula, that force formula is the rate of change of momentum, right? And we know that the force is the rate of change of momentum. This is the EM wave, right? That is normally incidenting, but the no reflecting is not there. That means during this the change in momentum is the initial momentum minus final momentum. Final momentum is 0 because EM wave does not reflect. The change in momentum is P. P is the momentum of EM wave. Momentum of EM wave. We know momentum of EM wave formula? Yes or no? Then from that we will get one formula, that is from the momentum we will get one formula, and that we have to divide with the time, and its derivation in the previous class I explained. That we will get as IA by C we will get. Okay, right, it was very simple. Then you substitute all values it here, where I is the 18 into 10 to the power of 4, A is the 20 into 10 to the power of minus 4, by C is the 3 into 10 to the power of 8. We have to simplify. This will cancel. Then we will get 3 6 18. 6 into 20 we will get 120 into this 10 to the power of 8 goes to numerator, 10 to the power of minus 8 Newton we will get. 120 into 10 to the power of minus 8 Newtons we will get. Otherwise this we can also write as 1.2 into 10 to the power of minus 6 Newtons. This is the solution. Okay, thank you for watching my lectures. If you have any doubt, you can ask me, you can message me.